Hey, how are you doing, guys? I'm Daha and I'll be your instructor for today's lesson. So let's get started. In this course, I'm going to explain to you a Work with Fast AI course, and here's a link for that course. In today's lesson, I'm going to discuss with you what is image classification, and I will show you how to build a model that can classify between a bit's images. So let's begin. In this lesson, I am going to cover all of these topics for you. So I will show you how to use Collab to open a notebook, and then I will discuss with you why we choose a GPUs for our deep learning projects, what is fast AI, and what data types it supports, how to install fast AI, libraries within FastAI, how to download the data, and what is data bunch, and what is data augmentation, what is normalization, and I will show you a general pipeline for our deep learning projects, what is data block API, how to make a vision learner, and what is a pre-trained models and how to train our model, and the last thing, an interpretation of our results. So let's begin with the first topic. So as you can see, here's my lesson one notes. um, the first topic is about how to use Colab to open a notebook. So here is the steps you need to follow. First of all, you need to open Collab and then choose a GitHub from this box here, and then search for a mod. So let me show you how to do this. So first of all, you need to open your browser and then search for Collab. Okay, open it. And here's the box. So you need to choose a GitHub from here and then search for malware. So as you can see, guys, here's all of repositories. So we need to open a practical deep learning for coders 2.0. And here's all of notebooks. So in this lesson, we are going to use a pets notebook here. So open it. Okay. So here's a notebook. Let me open my notes again. Okay, the second thing we need to do is to change our processor to a GPU. Why we need to do this step? Because GPUs are preferred for deep learning, because they are designed to handle a complex mathematical computations in parallel. So as you know, deep learning models involve a lot of matrix operations, which can be performed much faster on GPUs than CPUs. So that's why we need to change our processor. And here's the steps that we need to follow to change our processor to a GPU. So first of all, we need to go to runtime and then choose a change runtime type and then choose GPU. So let me show you how to do this. Okay, first of all, you need to go here to runtime and then change runtime type. Okay, and then choose a GPU and save it. So that's it. So now our environment is ready to use. So let me give you a quick glance about what is Fast AI. Okay, I will open my notes again. Okay, so Fast AI is a deep learning library that provides high-level API for training and deploying machine learning models. So as you see, here's my notes. So it is a library that built around neural networks to make the state of the art more accessible for people. It supports 5 data types. The first one is a computer vision, which deals with images. The second one is a tabular data like databases. The third one is a text data. Then collaborative filtering like recommendation systems, and the last one is medical imagery. So now I will show you how to install it. So there are 2 different ways to install it. The first one by using Editable, which involves pulling the GitHub repository, and the second one by using pip. So I will show you how to install it by using pip. So I will open the notebook again. Okay, this line of code will install it for us, so we will run it. You will run a cell by press shift and enter. Okay, run anyway. So we will wait about 1 minute. So now Fast AI is installed for us. Okay. So now we are going to import 3 different libraries that will help us for our task today. So there are a basics library, callback, and vision library. So vision library tells us that we are going to use a vision task. Callbacks gives us an access to various fit functions, and basics help us with some basics functionalities. So let's import them. Okay, this line of code here will import them for us. So let's run it. Okay, now the library is imported for us. So now we are ready to download our data. So we're going to use a bits data that Fast AI provides to us. So to download it, let me first open my notes. Okay, so to download it, we are going to use a enter data method here, which is a function that helps us to download and extract a compressed dataset from a URL to our local directory, and then it returns the path of the extracted dataset, which can be used later for processing or analysis. This function is commonly used in machine learning projects to quickly access and work with pre-existing datasets. Okay, so this line of code here, we are going to download our data and store the path of our data in a path variable here. In the second cell, we are going to set our seed, which is help us to have a reproducibility. So if we are going to um, run the same seed later, we will get the exact same split. Okay, so the last cell here is going to explore our path, and it display for us the name of the first 2 folders inside it. So let me show you. Okay, so I will run this cell and this one. Okay, so here we have 2 folders. The first one is images and second one is annotation. So we are going to, for this task, we are going to use a images folder. So for now we have downloaded our data. So I will open my notes again. Okay, let's build our data bunch, which is now called a data loader. So what is a data loaders or a data bunch? So it's a bunch of data that coordinated and pipelined for our model to go and read, because a model doesn't read a simple images, so we need to convert them into tensors to perform some calculations on them. So to do this, we need three different things. The first one is a path of our images, and the second one is our file names, and the last one is our class names, which is we are going to extract them by using regular expressions. So, okay, here's our path, and here's our file names, and here's our class names. And this part here is a regular expression to extract our class names. In this cell here, we are going to do some basic transformation on our image dataset. We are going to use a data augmentation, which is a process of generating new transformed versions of images from the given image dataset by using some techniques like rotating our existing images, enlarging them, shrinking them, or changing the contrast of them. Okay, so in this part here, we are going to do some normalization. So normalization is we are going to change our pixels value, so make them all follow a U-shaped. Okay, and here's my notes. So let me open my notebook and run the cells with you. So here's the path and file names and a class name, so run it. And here's our data augmentation and normalization. In this part here, we are going to use a random resized crop function, which is basically do random crop of images and resize them with a specified size, which is here a 460, and PS here refer to a batch size. So batch size is a number of samples that are processed in one forward or backward pass of a neural network during the training. So let's run it. In this here, in this cell here, we are going to build our image data loaders. Okay, so now we have built it. Let's review what we have covered so far. Let me open my slides again. Okay, so I showed you how to use Collab to open his notebook. Why we choose GPUs? So because they are faster than CPUs in deep learning projects. What is Fastai AI? The 5 data types that it supports, how to install it, and I showed you how to install it using pip in our notebook. So libraries within Fastai AI, I showed you that we are going to use three libraries: Vision, callbacks, and basics. How to download the data, what is data bunch, what is data augmentation, and normalization. So now we are going to discuss a general pipeline for any project. So I will open my notes. Okay, so this is a general pipeline for any project. So the first thing you need to do is to collect a data. After you collect it, you need to clean it and then train a machine learning or neural network model on it. So then you need to do a evaluation on unseen data. Why we need to do this step? Because to measure our model performance on unseen data. So if our model isn't good, we should go back and retrain it or do some cleaning again on our data. And the last step is to deployment. Okay, so let's go with a data block API. So we essentially have three different options here. Data bunch, which is now called a data loaders, data block, and pipeline. So let's begin with the first one. So a data bunch or data loaders. As you saw, it's a one-line call, so it's a highest level. Give you not much flexibility. Have four different options. The first one is a image data bunch or image data loaders, and segmentation data loaders, which is used for image segmentation. So if you don't know what is image segmentation, it's basically we have an image and we are going to divide it into multiple segments or regions, so each of which correspond to a different object or point of the image. So that's it. And then we have a and then we have a text data loaders and tabular data loaders. Okay, so the second one is a data block, which is a medium level API. It has a lot of more flexibility than a data loaders, and we will focus on that. So it have a image block, mask block, point block. So point block like we are going to trying to find the center of head, something like that. B box block, which is like a bounding box, and then text block, tabular pandas, and the last one is a pipeline, which is a lowest level API and give us the highest flexibility. We are going now to focus on a data block portion here. So to define it, we need first we need to define our blocks. That's gonna be your inputs and your outputs. So your outputs here is called a label. The second thing is to define your getters, how to get your inputs and how to get your output. And then you should define how you want to split the data. And then we need to label our data. And the last thing is to bunch all of these things together and build our data block. So, okay, here's how to define your input and output. As we saw image block, mask block, point block, okay, B box block, text block, tabular pandas. And these three blocks are category block, multi-category block, and transform blocks. So all of these blocks are built on top of a transform block. So category block is for your voice, your label, your output, and multi-category block here says that we are have a multiple categories. Okay, here's how to define your getters. We have here a get X and get Y. Get Y, how you want to get your labels, your output. Okay, so here's how to split your data. Okay, in today's lesson, we're going to focus on a random splitter. So it split our data within a given percent. Then we have a index splitter, grandparent splitter, func splitter, file splitter. So we are gonna go into this later. Okay, and here's how to label our data. So we have a parent label. Um, give our label the name as the folder that is stored in, and regex label call reader. Okay, and the last thing is our data bunch. So here we need a few different things. We need a path of our data block and a batch size. As I told you, a batch size is a number of samples that are passed to a neural network during a training, and then transformers. So for now, I want to show you how to build a data blocking code. So let's open a notebook. Okay, so here's we define our blocks. So our input block is going to be image block, and our output is a category block. Here's a get items, get item image, get image files that tell our models that we are going to use images. We are going to deal with images. Here we are going to split our data by using a random splitter. We are going to label our data by using a regex labeler, and here is a term of a Lagrange expression. Item transforms here, I guess you notice. Okay, so item transform here, we define it above, which is the resize images, and a batch transforms here is this line of code above, which is our augmentation and normalization process. Okay, so let's run it. And here we define our path of our images. Okay, so now we are going to build our data loaders. Okay, so this code, this line of code here is going to show us 9 images from our data loader. So this is our images, and dot vocab here is going to show us our category, and dot vocab dot o2i is going to rank our category. So in Bengal we have 1, for Perman we have 2, and so on. Okay, so let me open my note again. So what we are going to do now is to build a CNN learner, which is called now a vision learner. So to build it, we need to define our data bunch, which is we already built it, and then we should define our architecture. So our architecture is referred to a specific neural network model used for image classification tasks. These architectures are pre-trained on a large dataset. I guess you know about them, like ImageNet or VGG, ResNet. Okay, so and can be fine-tuned on smaller datasets. So then we need to define our evaluation metric, and then our loss function and our optimizer. Okay, so in this line of code, we are going to build our vision learner. So we pass it our data bunch, our architecture. We are going to use a ResNet 34, and then we tell it we are going to use a pre-trained model. So if you don't know what is pre-trained model is, so pre-trained models allows us to do something called a transfer learning. So instead of training a model for many epochs, we can borrow their weights. This helps us to train our model faster and improves the accuracy. And then we are going to use error rate metrics, and we are going to use Adam as an optimizer. Okay, so here we are going to train our model. We are going to train it by using a fit one cycle function and pass it the number of epochs that we want to do. So if you don't know what is epochs, so epochs are how many times we want to iterate through all of our data. So let me show you the code again. Okay, so we are defining our vision learner, and here's we train our model, so it will take times. So I wouldn't run it. So in the last step here, we are going to save our model. So by run this cell, FastAI saves our weights of models parameter to a file. This allows us to reload the model later and contain training or use it for a new dataset. So let's look at our result. So this function here in FastAI, it creates an interpretation object for our classification model. This object contains various methods to analyze our result of classification models, such as plotting a confusion matrix, calculating the accuracy, and displaying a top losses. So let me show you. So here's our top losses. These images here are a top 9 images that our model is missed to classify. So the first part is going to be a model prediction, and the second part is our actual label, and then the loss, and then a probability. So for cat here, our model predicts it a Perman, and its actual label is a ragdoll with loss 6.32 and probability 0.97, and so on for all of these images. Okay, so here we are going to plot our confusion matrix. So as you can see here, these are our actual labels, and these are our predicted labels by a model. And then here we are going to display the top 3 labels that our model is confused about them. So for the first row here, the model predicts that it's a ragdoll, and the actual label is a Perman 7 times. And for the second row here, our prediction was Egyptian Mao, and the actual label is a bungle. So our model confused about them 3 times, and so on for the third row here. Okay. So in this part, we are going to unfreeze our model. So first of all, we need to load our old model again. And then we are going to unfreeze it by using unfreeze method, which is unfreeze all of our network layers. And then we are going to retrain our model by using a 4 epochs, and these are results. Okay, so here we are going to find an optimal learning rate for our old model. So we need to load our old model again, and then we are gonna use a lrfind method, which is plot our learning rate and our loss function. And then to find a optimal learning rate, So optimal learning rate is with a loss function with a pretty small. So as you can see here in 10 to the power -6 to 10 to the power -4, our loss is pretty small. So in this interval, we assume that an optimal learning rate is fail on it. So we are going to freeze, we are going to unfreeze our layers again, and then we are define our interval. So 10 to the power -6 to 10 to the power -4, and then we retrain our model uh, by using for epochs. And the last thing we do is to save our results. So okay, so that's it for our for this video, and I will make a separate video to show you how to build a model with a custom data.